Hi everyone, thank you very much for that intro, Justine, and thank you for doing all the housekeeping, Greg. It's lovely to be back running another one of these courses. I took one a few weeks ago now and was able to take that module as the first one where we were going through more about the international space and our requirements from a governmental side, but also from a supply chain side. Today is module 3, and I'm going to actually push my video away now just so that you focus on the slides and I don't obscure any of the great detail that's on the slides. So module 4, sorry, today obviously you guys had the soil module earlier on as well. Normally when we run this, so if I say module 3, I do mean module 4, is around accounting and carbon accounting. I think it's going to go to the next slide. Oh, there we go. So just a brief introduction. I know some of you would have heard the main intro before. So just briefly, I work for Environmental Accounting Services. We are a small consulting company that basically specialises in greenhouse gas reporting, estimation, verification, supporting businesses, landholders, governments to report their greenhouse gas estimates to international best practice standards. So with this module, I am right in my comfort space. It's something I do on an everyday basis. In terms of my background, I grew up on a sheep and beef property in New Zealand. That's me and my best mate Trevor, who I still get to run every time I go home to the farm, which is lovely. And I've been heavily involved in greenhouse gas accounting and the agriculture and land sector. In terms of relevant projects that I've been working on recently, a review of calculators for greenhouse gas emissions in the agricultural space in Australia. Was something I completed earlier this year, and that was sort of in the lens of helping to inform supply chains as well as user friendliness of the tool from a farmer point of view as well. So looking at both sides in terms of how you're reporting those things and who you're reporting to, as well as how useful those tools are in the input side as well. We'll talk more about tools later on in this topic, and also heavily involved in terms of national land monitoring systems, so looking at land accounting from different land use classes and different land use types. So that's something that I'm really involved in developed and developing nations alike. So what are we actually going to cover today? Justine mentioned in the intros, we're going to look at definitions, because as she said, words do matter. So there's a lot of confusion sometimes in the space and things are always changing. So in terms of defining what carbon is, because we all know that carbon is actually an element on the periodic table. So what are we talking about when we mean a carbon account or carbon neutral? The carbon cycle in agriculture, and hopefully I have a video there, will just show the flow of carbon through the agricultural cycle, and then carbon accounting and carbon footprints, and again more terminology, and also how we're setting our boundary and how we're delivering that information to potentially to our suppliers or to the audiences that we're trying to address. So first up, definitions. Carbon farming is the management of principles that minimise greenhouse gas emissions, maximise carbon sequestration in the landscape while improving productivity and resilience of agricultural systems. Now this definition is very specific to Australian agriculture. So carbon farming isn't necessarily a word we use globally or internationally. It's something that Australia has almost adopted and defined, and it's the basis for things like the ACCU scheme to allow that management principles of minimising greenhouse gas emissions and maximising carbon sequestration to be rewarded. And so, but there's also taking into the account that obviously those systems need to be productive and resilient to the effects of climate change and just productive businesses in general. So I think carbon farming is a really nice, it's a nice sort of thing to aim for, and it's why this course focuses on carbon farming because we want to not only reduce emissions, increase sequestration, but also improve that productivity and resilience of agricultural systems. So we don't want to look at one of those things in isolation. We don't want to focus on just sequestering carbon and actually not improve our productivity or decrease productivity in that sense. Carbon neutral. Carbon neutral is a term that's used very broadly and used a lot outside of the agricultural sector. So you might have heard of, a Qantas being carbon neutral, or any kind of business can sort of claim carbon neutrality if they follow due process. And the process is generally that they will measure their emissions. So they'll do a greenhouse gas account to a certain standard, generally ISO 14064. We have a little bit more discussion on standards later, or the greenhouse gas protocol. So they're measuring at least ideally 95% of, or estimating, measuring is the wrong word because it's an estimation, but estimating their emissions, 95% of their emissions at least, and then basically they are purchasing offsets. So it could be ACCUs in Australia, or it could be voluntary carbon offsets that are equivalent to their emissions to reach carbon neutrality in a single year. So carbon neutrality is generally a term that's only used for a year, and it's usually applied by a program which has some sort of verification standard. So you might have heard of Climate Active is the big one in Australia. They provide carbon active, carbon neutral stamps. So you can go to Climate Active, say, here I've done my account, and then you'd say, okay, cool, I've got my account, now I want to buy equivalent offsets and cancel those. So that's the other thing with carbon neutrality, is you're buying the offsets, cancelling them for that year so you can make that claim. And so you can see that carbon neutral and carbon farming are quite different. Net zero is different altogether, and net zero is what we talk about when we're talking about our Paris targets. So Australia has a net zero target for 2050 for its whole as a country. And the idea of net zero is that you actually have to reduce greenhouse gas emissions to as close to zero as possible, with any remaining emissions reabsorbed from the atmosphere by oceans or forests. So the difference between net zero and carbon neutral is that net zero, you're actually working on reducing emissions first before considering any kind of offset. And it's generally a longer term goal. I'm not sure if anyone will have heard of the science-based targets, and potentially we can talk more about it in question time if you'd like to go more into the science-based targets discussion. But companies that are setting science-based targets are aligning with this concept of net zero in terms of what reductions do we have to make to be on and matching that line to meet our Paris Agreement targets, to be 2050, net zero by 2050. And therefore, often this requires more money being spent on emissions reductions rather than considering the sequestration piece until later down the track. Climate neutral. So the UN definition of climate neutral is actually very similar to net zero. However, climate neutral has been used in various different concepts, and I think the industry groups like MLA Australia have picked up climate neutral and are using it in terms of a no net warming concept. So the definition on climate neutral varies and can be quite ambiguous sometimes. So I guess in terms of carbon farming, carbon neutral and net zero, those three are very well defined. Climate neutral, however, can vary depending on the context that it's used in. So hopefully everyone feels a little bit more confident about those three words now. And I guess in terms of why we use carbon, and you might know I will say greenhouse gas often, and I could interchange that with carbon. It's basically carbon is short for carbon dioxide equivalent, where we are associating all of the greenhouse gases. So methane, nitrous oxide, and carbon dioxide are three major ones from agriculture, as you can see on the slide there. And we are basically making those equivalent with what's called GWP 100 so that we can report tons of carbon dioxide equivalent or kilos of carbon dioxide equivalent. And so over time, carbon dioxide equivalent is quite a mouthful, and it has slowly and slowly become carbon. But obviously we're not, unless we're referring to carbon sequestration, we're actually referring to the storage of glucose in a plant, we're actually referring to tons of carbon dioxide equivalent or greenhouse gas emissions. So more terminology, if you're not too bored yet. We have two definitions here of a carbon footprint and a carbon account. And basically, in terms of a carbon account, we might hear me say greenhouse gas accounting or any of those kind of words. We're talking about looking at the annual change of, in terms of annual emissions from an entity, like a farm, and the annual change in soil and tree carbon on the sequestration side. So annual emissions from a greenhouse gas, annual emissions of greenhouse gas from a farm are things like methane and manure, causing enteric, methane from enteric methane sources and methane from manure sources, as well as fertilizer, energy use, those kinds of things. And then on the sequestration side, as I said before, trees and soil. But we don't, I guess the point that I want to make here, and why I'm tying myself in knots a little bit, is that it's very easy to consider the emissions for a year of, say, your enteric methane, because you're just looking at a calendar year and you're saying, I had this many animals on my property for this year, and in that time they ate this much food, and therefore they emitted this many emissions. And of course, that's a very simplified estimation. But when we compare that to trees and soil, the complexity there is that we need to know how much those trees are growing in that year, or how much that soil would be increasing in soil carbon in that year. So people often get confused between stock of carbon and annual change or flux. So you can only include not the whole stock of the tree, not what's been growing over there for 30 years. What has changed between year 30 and 31 would be what's included in that account. And so that's to just make sure that you're adding or subtracting like for like, rather than taking into account the stock of the sequestration and comparing that to the annual emissions. In terms of what year you choose or how you choose the annual year, it's up to you whether you go from the 1st of January till the 31st of December, or whether you start from your financial year. Most businesses will use their financial year just because it's easier to collect the information that way. But it really depends on the entity and how they can best collect their data. Something that's included on the slide, and I'll talk a little bit more about it in a bit, is the Scope 3 emissions. So that's on slides coming up, so I won't label it here. The definition of carbon footprint is about emissions intensity. So basically, when we have what's called net emissions, and that's just basically the emissions from an entity minus the sequestration equals the net farm account. So it's just it'll be 1,000 tonnes of CO2 equivalent per year, potentially. That's just a number. Whereas your carbon footprint or your emissions intensity is taking that number and actually dividing it by the tonnes of product produced. So if you're producing beef, it's how many kilos of beef did you actually sell versus how many emissions those animals created. And so that, in terms of emissions intensity, it's something that a lot of the supply chain are interested in, because they will be looking to purchase low emissions intensities products. And so this, and because that reflects on their Scope 3 emissions. So I'll get into Scope 3 emissions next, but hopefully that makes sense in that we have two different ways of looking at an account. You can look at your net emissions and just how many, what has been emitted to the atmosphere versus what have been sequestered down in a year, just a number, and then what about how many emissions are associated with the tons of product you produce? Emissions intensity. So going deeper into this, having a better look at this ins and outs, we can see that there's also this indirect scope 3 emission source. And interestingly, in most cases outside of agriculture, businesses, this scope 3, this upstream or downstream emissions is normally a lot higher than your scope 1 and 2. But because agriculture is primary producing and primary production, it'll actually be the scope 1 and 2 that generally are your highest emissions. So I've mentioned scopes, and this will actually define what these scopes are. So scope 1 are direct emissions owned and controlled by the sources. So this is the animals that you own, the fertilizer that you buy and apply on your land, and so the emissions are occurring within your farm boundary. So all of these things that basically you own or have control over. Scope 2 emissions are indirect emissions from electricity. That sits on its own scope and always will sit on its own scope. And that's because it's basically, it's the way the accounting construct works due to the who's responsible for the ownership and sale of that product. Scope 3 are those upstream or downstream emissions that occur in the company's value chain. So this is if you're selling cattle and they go on somebody else's truck to either store or to the abattoir, then that truck that they're going on is owned and operated by someone else, and that's their scope 1 emissions from that transport, but your scope 3. In terms of pre-farm inputs, it's things like what we call embodied emissions, so the energy that it takes to make fertilizer, to make baleage or hay or feed source grain, and that's embodied in that product because obviously some energy goes into producing that product, and that's actually sitting on someone else's, the producer's scope 1 emissions. So something that often comes up when we start talking about scopes is that, aren't you double counting? How can we possibly have, if there's a transport company that's got scope 1 emissions that you're including on your scope 3, that's double counting. But because that's why we have the separate scopes to separate them out. So as long as it's not being counted twice on someone's scope 1, then it's not double counted because it's someone's scope 1's, your scope 3's. And the reason that this accounting construct exists like this is to drive change throughout the supply chain. So in terms of the way someone like Nestle or any of those big food companies, even the smaller ones in Australia like Coles or JBS, or who are interested in the supply chain, their scope 1 and 2 emissions won't actually be as a result from the product they're buying from you. You're sitting on their scope 3. And so they're incentivized to make change over time because they want to say, I want my product, my Coles carbon neutral beef, to be carbon neutral, therefore I have to go out and measure my scope 3s and report on them, and buy the equivalent offsets to be able to make that product carbon neutral. So this way it doesn't leave, say, producers who will have a really high scope 1 and 2 compared to their scope 3 sort of in the lurch dealing with all of the change on their own, while a business like JBS can say, oh, well, our scope 3s don't matter because they're someone else's scope 1s, and so we don't have to, we can ignore those. So it basically makes big companies, Nestle, whoever, responsible for helping those people within their supply chain to reduce their emissions over time, rather than just pretending that it's not their problem and it's not something they can do anything about. Other things to note with greenhouse gas accounting is that whatever tool or methodology you're using to conduct your account, it has to be aligned to your NGGI, so your National Greenhouse Gas Inventory Method. So the way Australia reports its emissions to the UN to meet its Paris Agreement and things, it has a report with a methodology that says this is the way that we accounted for emissions from livestock in Australia, and it will have equations and emissions factors and activity data. And then if you're within Australia trying to make a measurement of your emissions, you need to make sure that however your reporting is not inconsistent with the way the National Greenhouse Gas Inventory Method conducts that. And that will be different. So the method for Australia is actually different to the method in New Zealand. So that you can't just pick up a tool that works in New Zealand and apply it in Australia. So that's why there's Australian specific tools for calculating your emissions, because it needs to have this, well, not be inconsistent with is the way the terminology is, that International Panel for Climate Change approved National Greenhouse Gas Inventory Method. So this is just a diagram that I wanted to bring in to explain how, in most cases, that, you know, the big companies that we're talking about, the Nestle's of the world, will have huge Scope 3 value chain emissions, whereas their direct Scope 1 and 2 emissions will be much lower. This is flipped for agriculture. Because it is primary production, the Scope 1 and 2s are generally higher than the Scope 3s. But you are somebody else's Scope 3. And that's kind of the key thing to think about when you're thinking about reporting, is that your Scope 1 and 2, well, your Scope 1 emissions in particular, are someone else's Scope 3 emissions. So when you're reporting in your value chain, that's the emissions you need to be most clear about reporting, because that's what that value chain is going to want to know. So I've already talked a little bit about tools, but this slide should give you some more detail on that. So some of you may have heard of the GAF tools, Greenhouse Gas Accounting Framework. And so these tools have been put together by PIC, and they are the research institute out of the University of Melbourne, who spent a long time looking at the Australian National Greenhouse Gas Inventory Method and reproducing those equations in a calculator for a farm-specific account. So these tools are aligned to the Australian National Greenhouse Gas Inventory. They use the correct emission factors from that inventory and the similar equations. So these are Excel-based tools, and they can be found on the PIC website. They're free to download. Over the years, there's been significant development and revisions. So we've gone from having just the sheep and beef GAF, SB GAF, to having a really good range of tools for different industries in Australia. It's even gone from having just a cropping tool to now having a sugar, cotton and horticulture tool, which have all been built alongside industry bodies to make sure they're more relevant. There is, I guess, some user interface difficulties in the sense that it is just Excel, so it's not a web-based tool, which does make some of the I guess the more difficult for some users who aren't familiar with Excel. But the good thing about it is if you're interested, you can actually go and look in the back sheets and actually see all of the emissions factors and calculations and how it actually works. So it's a very good educational tool, and it's what we use in these workshops when we are working with farmers and also rural professionals to get an understanding of their emissions, and so we use it as an educational tool. It has pluses and minuses, but it is one of the few tools that is consistent with the Australian National Greenhouse Gas Inventory methodology. In terms of how you can measure carbon stocks and fluxes from vegetation and soil, The Australian inventory uses FullCam. I'm not sure how familiar you are with FullCam, but it is, I spoke about it a little bit in Module 1. It's a Tier 3 model, which means that it is a model rather than a set of emissions factor and activity data. It is very complex and takes a lot of information, takes satellite imagery, climate and soil data, land cover change data, and then is able to forward predict how much vegetation will increase or soil will increase or decrease over time, depending on certain actions being taken. So because that is consistent with the greenhouse gas inventory, is the method that can be used to assess changes in vegetation and soil on farm. The SBGAF tools has a very simplified version of basically in terms of its carbon sequestration capacity, because it's only spreadsheet based and FullCam is a very complicated model. It doesn't have all of FullCam in it. It has a certain number of runs of FullCam on different soil types for different regions, and they're summarized as what we call a lookup table. So the carbon accounting or the carbon stock accounting within carbon sequestration accounting within the GAF tools is limited, but it can give an indication at least. The other options is direct measurement, so you can actually go out and cut trees down, measure the rings to be able to work out their age, to be able to work out their carbon stock. We do plots, and you do a certain number of plots per area to understand the action. This is obviously the most accurate way to understand a carbon stock of a forest, is to actually go out and do direct measurements on the plots, looking at and use allometric equations based on the age and also the diameter at breast height of the vegetation there. Or same thing with soil carbon, you're looking at doing core samples and getting a measurement that way. But FullCam is the other option. It says Flint/Flint Pro there. Flint Pro is basically a version of FullCam that's been given a better interface, so it's more user-friendly for farmers or non-skilled users to interact with. FullCam is free to use. It's downloadable off the federal government website, but it does take a little bit of learning to get the hang of it. But there is detailed instructions on that as well, so it is usable. And in terms of there is also the Socrates soil carbon model, which has been put together by the university. I'm not going to remember off the top of my head which university, but Australian University. Oh goodness! But it again, it's not what's used. It's very similar to the equations that are in FullCam, and so it's potentially not inconsistent with the Australian inventory. In terms of other tools that exist, there's lots of them, and you might have heard of some of them before. So you might have heard of the Cool Farm tool. It's very well known internationally. It was started in the UK and has sort of grown from there. It's very high level. It's a web-based interface, so it is quite user-friendly. But they use what we call Tier 1 data. So as I was saying, Australia has Tier 3 data for its forestry sector in terms of FullCam, soil and carbon sequestration, and then it will use Tier 2 data for its emissions estimates. So it will have, in some cases, state-specific, but normally nationally specific emissions factors, and nationally specific activity data on the number of animals and things like that. Whereas Cool Farm tool relies on what's called Tier 1, so international averages for emissions factors, which therefore makes it not consistent with the Australian National Greenhouse Gas Inventory method. So if you were trying to use one of these tools to go for climate active certification, say you wanted to be carbon neutral under climate active, they wouldn't accept the Cool Farm tool because it is not consistent with the Australian National Greenhouse Gas Inventory method. Also, your supply chain is unlikely to accept that because they are having to follow those best practice guidelines, and they're obviously following that verification process. So using a tool which is consistent with the National Greenhouse Gas Inventory method is really important. Farm print is something that has been in development for quite some time, and I'm unsure of its current status. As far as I know, it's still in development. It was meant to ideally focusing on broad acre cropping initially. It was going to go from cradle to farm, so basically taking into account all of those scopes of emissions, including scope 3 from pre-farm emissions. The Look-See tool is an interesting one. So the Look-See tool is not a tool that is for carbon accounting per se. It's not for understanding what your farm's greenhouse gas emissions are, but it is a very helpful tool for understanding what emissions reductions funds activities could be viable on a farm, a farm basically, on what in a certain area. It's really nice, user-friendly, very farmer-facing tool where you can go in, put your farm boundary, answer a short questionnaire about your farm and about what sort of things you're focused on, and it will suggest based on your location, your soil type, all of the information it can get out of the back of FullCam, what ERF methodologies might be suitable to undertake on your farm. So I really rate the Look-See tool. It also can give slight estimations of sequestration as well. So if you want to do a sequestration project on a certain area, it can give you sort of an estimation on what sequestration rates may be achieved in that area, once again based on FullCam. So it's a very handy tool and very high functionality in terms of usability. GAF tools are up there again. DGAS is basically just a GAF tool with it's just in a different interface, wearing a different dress. It is including pre-farm emissions, so including scope 3. It's used in some ERF methods for dairy, and so that's why it's been slightly changed from the straight up GAF tools. FullCam I spoke about. I guess a couple of points that I missed is that it's spatial. It's the great thing about FullCam. So if you know your boundary of your area, you can actually look at the carbon sequestration across that boundary spatially, not just at one point in time. And yeah, you can look forward and based on different management actions, what will occur. So it's a modelling tool as well. A new one I've put up there that I'm not sure if anyone's heard of, but Ruminati is basically a tool that was based on SBGAF that has had some modifications. It requires less inputs. It uses DSE rather than a number of animals in different stock classes. So it's a simplified version, very farmer friendly in that way. And the interesting thing about Ruminati, which unfortunately the GAF tools don't have the ability to yet, is that it has an emissions reduction planning aspect. So you can actually say, okay, these are my emissions today. What am I going to do to reduce my emissions in future? It's only for sheep and beef, so they haven't expanded into cropping or anything like that yet. But it is quite a useful tool. And it will be interesting to see how they develop it further with that emissions reductions planning aspect, because again, that what I was speaking to earlier around science-based targets and that whole big companies setting a trajectory to be in line with either net zero at 2050 or meeting our 1.5 degree targets under Paris, they will may support those businesses to do that by having that emissions reductions planning aspect and giving businesses an understanding of, okay, how can I reduce my emissions over time incrementally. The other couple of tools which I think are quite interesting and not on this list would be, I had some questions on module 1 about aquaculture and fisheries. There is an aquaculture and fisheries tool for both onshore and offshore. It's been put together by a consulting company called Blue Shift Agriculture, but was funded by FRDC, I think, and it's a great spreadsheet-based tool, very similar to the GAF tools, but a lot more simple, because in those agriculture and fisheries industries, a lot of the main emissions are fuel rather than methane or nitrous oxide, which is a bit has much more complicated equations associated with it. The other tool, thinking of the Queensland area, is there's a horticulture tool. Obviously, there is the one with the GAF tools. But I think it's called Hort Farm Smart Info or something along those lines. It's actually linked on the PIC website as well, and it's a web-based version of a tool, and it's much more detailed than the GAF horticulture tool. So if you are a horticulturalist, I would recommend that tool over the GAF one, just because it has more a greater number of inputs and more, a greater number of crop types and things like that. So it is very good, but it is linked on the PIC website as well. So if you go there looking for it, you should be able to find it. So a bit of a change now. So we've talked a lot about, I guess, greenhouse gas accounting and the frameworks that we work under, the standards we work under, and the ways we have to align with our national greenhouse gas inventory, the tools that we have to support different farming systems, and actually aligning to that and making those changes. But this now is going more specific towards actually the science of how this carbon cycle is occurring in agriculture. So this is not, obviously, when we do a greenhouse gas account, we have to very much simplify this carbon cycle into a balance sheet type approach, whereas this is the full cycle. But it's good to have an understanding of both to see how we are having to simplify these things into accounting construct for what we're trying to capture in terms of emissions and sequestration. So I'm going to hope that this video will run, otherwise I can talk you through on the next slide as well.
This is an explanation of the carbon cycle in agriculture. It's based on a grazing system, but the same principles apply to a cropping system. It all starts with sunlight energy and the process of photosynthesis in plants, which allows plants to capture carbon dioxide from the atmosphere and lock it away into a plant. You will notice that we've highlighted the letter C in its various forms of carbon, showing that carbon in CO2 is a gas, but carbon in the plant is CHO, which is a sugar, not a gas. The key point is that carbon takes many forms as it cycles through our agricultural systems. In a cropping system, we would then harvest that plant. In a grazing system, an animal will graze the pasture and convert the carbohydrate into animal products. The majority of the carbon consumed by the animal is belched out or breathed out as CO2 back to the atmosphere. The majority of the animal products or crop products eaten by humans is also respired back to the atmosphere within 12 months as CO2. If that was all that happened, the carbon cycle would be completely balanced, with all inputs returning to the atmosphere in the same form within a short period of time. However, a small amount of carbon entering the rumen of the animal is converted into methane, CH4, which is carbon in another gaseous form. Methane is fundamentally different to CO2 and has a far higher warming potential in the atmosphere for the duration that it's there. The animal defecates, and so there's fecal carbon in an organic form going back to the soil. Plants will leave litter on the soil surface as a form of organic carbon. As the plant grows, it produces roots, and these roots leave carbon behind either as root fragments or as root exudates of sugars. This organic form of carbon in the soil can either be in a larger fraction, which we call the particulate organic carbon, and turns over fairly fast through microbial action, perhaps in hours through to a few years. The smaller, more resistant fractions of organic carbon in the soil are called humus. These are the more resistant fractions that last for decades through to hundreds of years. In the soil, there are billions of microbes that then work actively on this organic carbon as their food source, actively breaking down the carbon to release the stored nutrients back to the soil to allow the crop or pasture to grow. In the process, these microbes then release the carbon stored in the organic material as carbon dioxide back to the atmosphere, and the carbon cycle completes itself. In a cropping system, this process of mineralization may release 30 to 50 kilograms of nitrogen per hectare per year out of the soil organic matter. In a dairy pasture system, it can be as much as 250 kilograms of nitrogen per hectare per year from the organic matter. The point of carbon farming is to capture and make that cycle as efficient as possible, that we can transfer as much of the carbon from the atmosphere into product that we're interested in producing, which could be meat, wool, milk, grain, and crops. Carbon farming is therefore focused on maximizing the carbon from photosynthesis through to a product that goes to market as efficiently as possible. In the process, good carbon farming would aim to leave as much carbon in the soil as possible, capture some of the carbon in trees growing in the landscape, and minimize the amount of carbon lost as methane and as a nitrogen gas.
Trying to make all of this make sense for the industry and what we need to do going forward. Basically, knowing your baseline is key in these scenarios, because you can't change what you don't know. Having that estimation of your emissions based on, say, the gas tools or any of the other tools I've spoken about today, or at least knowing what data to keep. So that's the other thing with doing first run at one of these tools. It gives everyone an idea of, oh, I don't know what my kilowatt hours of electricity are. Where do I go and find that information? How can I keep that information going forward for when my suppliers come and ask for that sort of information? Or, I need to have better stock rec to therefore be able to put in, my changes through the seasons of my different classes of stock. So I need to have better stock records. So doing a baseline, it's good for one, with the data that you have so far. It's really good to understand what is the biggest sources of emissions you have on your property. So even if you only have limited data, you can still get an idea from that first initial baseline. Okay, what are my biggest sources of emissions, and how am I going to make a plan to reduce those? And secondly, you can say, okay, what data do I have? What data do I need to get better at recording? And how am I going to make sure that this is replicable in future? So how am I going to replicate this year on year to see what changes are happening? To note there that the CN30 goal from MLA doesn't mean that each farm needs to be carbon neutral by 2030. That is a cross-sector goal, so it's not cross-sector, it's within the sector, but it's across all farms. So some farms will find it easier to be carbon neutral than others, and so the idea is that they're looking across the industry and trying to get to that carbon neutrality point by 2030. And supply chain targets are not requiring carbon neutrality either. So supply chain targets are generally looking at emissions intensity, and as I was saying, around the ones setting these science-based targets are looking at how they can reduce their emissions over time, looking potentially at net zero at 2050 or a certain reduction by 2030, depending on the target they've set. But it's not necessarily that all suppliers will need to be at that point. It's how it's dealt with as a collective But something that is likely to see happen is that suppliers who have these targets potentially are going to look at preferential purchasing based on emissions intensity. So how much emissions were created to produce how many kilos of product will be a key metric for anyone in the supply chain looking to meet targets. So it talks here about planning with first step, starting with do now strategies. The do now strategies are coming up in future webinars. There's do now strategies for methane, do now strategies for nitrous oxide, do now strategies for sequestration in trees. So that's something to look forward to in terms of what strategies can we actually use once we know our baseline using these carbon accounting frameworks to reduce our emissions over time, and how do we report those? Because again, this is what these tools and this module is about. It's about estimating and reporting those things that you're actually getting on farm. And there's often times that plenty of good things are happening on farm, but you've got to be able to capture and report it in some way to your supply chain to allow that to be of benefit. So this is, I guess, what this whole module focuses on. Noting that trees and soil are short-term options. So in terms of the sequestration over time, as I was saying, you're only taking into account on your annual accounts the change in tree and soil carbon in that year. So if your trees are already 50 years old, it's unlikely that they are going to be growing any more from age 50 to 51. They're likely to be in a state of neutrality themselves, basically. They're losing leaves and dead wood and not necessarily growing and sequestering additional carbon. So if you're planting new trees, they will be beneficial in terms of a sequestration option till they become fully grown, and therefore after that they obviously provide co-benefits, which are the main driver. And in the tree section, that's something that will be discussed in detail, the co-benefits around planting trees and how to focus on those and that, rather than necessarily just considering the carbon offset aspect. And also that ties back into that carbon farming definition we spoke to earlier, where carbon farming is not only about the productivity in terms of the minimizing your emissions and maximizing your sequestration, it's also about producing a good product and producing it efficiently as to result in those result in not only net emissions reductions, but intensity of emissions reductions as well. And then also just the note there about carbon credits versus low carbon. So if you're going to follow, I was saying earlier about look-see, and you can look up different ERF projects that you could undertake on your property. If you are going to then sell those ACCUs that you generate from that ERF project, you can no longer then cancel those against your own accounts, because you've sold them to somebody else, because they want to make a carbon neutral claim. So they're going to take those and they're going to cancel them against their account, so they don't longer belong to you. And so you can't do both at once. You can't include that sequestration on your account and also sell it to somebody else. It can only be used one way or the other. So you can generate ACCUs and hold them and cancel them for yourself if you want to use them against your own accounts. And we'll see if it comes up in the questions, but there are guidelines around insetting in this space as well. And then, or you sell them and therefore you no longer have access to that source of either sequestration, or if it's an emissions reduction project, those ACCUs which you're generating and selling. So just be wary of that, and especially on the sequestration side, if you have a soil carbon or tree carbon project and you're selling those to someone else who's using them and cancelling them, you are still liable for the permanence of those projects. So you still have to ensure that carbon stays in the ground for 25 to 100 years, depending on the scheme that's been selected there, or that tree stays standing for 25 to 100 years to ensure that cancellation on that other person's account is genuine. So you get left with liability, but not with benefit if you do sell those credits. So it's just going in eyes wide open. No, I'm not saying don't ever sell credits, but I'm just saying understand that it will or could impact your ability to report those aspects on your own accounts in the future. And so I think that's all I've got for this section. But I'm sure there's a lot of good questions happening on the chat right now. So I'll hand back over to Greg to read some of those out, and we can hopefully answer some of those.